Consider this question. It reads, two parallel conducting rails are connected to a source of EMF E and internal resistance R. Another conducting rod of length L having negligible resistance lies at rest and can slide without friction over the rails. A uniform magnetic field B is applied perpendicular to the plane of the rails. At t equals 0, the rod is pulled along the rails by applying force F. The velocity of the rod is observed to be as a function of time as v is equal to v naught cos omega t. What we need to find is the power spent by this force over one cycle. It will be this kind of relation, and we need to identify what this n value is. If requires, numerical values are also known to us. Also, this is the figure. This is a rod of length L, and this is internal resistance R of the battery of EMF E, and it's applied a force F t equal to 0, right? So when it is going to move as in its general time t, it will acquire some velocity v. Now, at the moment it has a velocity v, you will find there's going to be EMF induced on this wire, motional EMF. So because of motional EMF, this wire or rod is going to have an EMF or battery induced EMF of BLV, because B, L and V, all three are mutually perpendicular. And this will have a polarity. This is positive, this is negative. You can check for the polarity. Then you can think of, at this instant of time, this loop can have a current. Let's say that current is I on this loop. So Kirchhoff equation will say the current in the loop is going to be I is equal to net EMF, which is E minus BLV divided by resistance. Or you can say, you can apply Kirchhoff's loop's law. Now then, there will be current flowing there through this rod, conducting rod. Whenever the current flows through a conducting rod, there is a force IL cross B if B is uniform. So this wire is going to experience a force because of the magnetic field in this direction, and it will be IL into B. So net force will become the force that has been applied and the force coming because of the current. This net force must be equal to mass into acceleration, that is m dv by dt. Now we can put the value of I on this expression. So if we place the value of I on this expression, it will be this F plus this BL, and then I, which is E minus BLV divided by R, is equal to m dv by dt. Now we have been given that the solution of this, after solving this, if we find out this V value, velocity, it will be as a function of time, that is given V is equal to V naught cos omega t. Now we can substitute the V value on this expression and find out the force applied. So the applied force is going to be equal to m dv by dt, so just differentiate it. So it's going to be V naught omega cos omega t with a minus sign. And let's bring this term this side. So this one term will be minus BL E upon R. And you'll find another term will become B square L square by R. And then V is going to be written as V naught cos omega t. Now this is a force. So we have calculated the force that has been applied, how it is going to depend on time. So it has to depend like this in order to get this result. Power delivered by this or spent by any force is given as force dot velocity. And since both are in the same direction, so it will be like FV cos theta. So it's like F into V. So F is this, V is this, we need to multiply them. When you multiply them, then you're going to, this term will become minus m omega V naught square cos omega t sin omega t. This term will have a V multiplied. So that's minus BLE upon R into V naught cos omega t. This will have further V multiplied. So it's going to be like B square L square R V naught square cos square omega t. Question asks that we need to find the power over one cycle. That means it has to be average power. And what we have calculated is the instantaneous power. So whenever we need to find the average out of instantaneous, you know how to find the average value. So we need to make the average of this term, average of this term, average of this term. Now it can be written as a sine of 2 omega t by multiplying and dividing by 2. Sine 2 omega t, average of sine 2 omega t is over one cycle is 0, or one time period t time period is going to be 0. This is cos omega t, again cos omega t average for a cycle becomes 0. This is cos square omega t, cos square average over one cycle is half, so that will be half. So it will become b square l square v naught square by 2r. Then you compare this, so n must be equal to 2. So n must be equal to 2. That become our answer. Okay, thank you.